we are continuing with Chapter 6 and hypothesis testing, and we are working on a problem that is analogous to number 4 in MyLab Statistics. So let me go ahead and read the information in the problem here. So in the given study, the samples were given an experimental treatment, and the researchers compared their results to the general population. So we're going to carry out a z-test using the 5 steps of hypothesis testing for a two-tailed test where p is 0.01. And then we also want to go ahead and figure out the 99% confidence interval for this study. So first let's think about what our null hypothesis and what our research hypothesis are going to be. So our research hypothesis is going to be that the mean of the populations are not the same. That's our research hypothesis, that the mean of the populations are not the same. Our null hypothesis is that the means of the populations are the same, that the mean of the populations are the same. So that's our research hypothesis and our null hypothesis. The next step that we want to do is we want to go ahead and figure out what our cutoff score is. So what's our cutoff score for doing this z-test? Well, we know that we are going to be doing a two-tailed test. We're going to be looking where our p is 0.01. So when we're thinking about the area that's underneath the tail, if we were doing a one-tailed test, we would look at percentage of the tail of 1%. So we want to go ahead and we want to take, remember we have a two-tailed test. So we're thinking about the percentage for two extreme cutoff values. So we're taking 1% and we have to divide that into 0.5% and 0.5%. So 0.5% and 0.5% is 1%. So you can go ahead and you can click on the PDF that is associated with this example, or you can go ahead and look at Appendix A-1 at the end of Aaron et al. That starts on page 431 in the text. And so when you click on the PDF or when you look at table A-1 at the end of Aaron et al., you're going to be looking for where the percentage of the tail is 0.5. So go ahead and look for 0.5, and when you're looking there, you'll see that actually we don't see 0.5 there in the tail. We see 0.49 and we see 0.51. And so what we have to do is we're going to go ahead and err on the more conservative side, and we're going to use the percentage of the tail of 0.49. The reason why is because that gives us a slightly higher cutoff value, which is the more conservative thing to do in this situation. So we see that our values for our cutoff score are a positive 2.58 and then also a negative 2.58. So our cutoff scores are a positive and negative 2.58, this should be. So now that we know what our cutoff score is, we can go ahead and start working on this problem. So we have this information here in the problem. We know that we know what the mean of the population is. We know what the standard deviation of the population is. We know what our sample size is. We know what our sample mean is. And now what we need to do is we have to go ahead and find the standard deviation of the distribution of means. So the standard deviation of the distribution of means is SDM, and SDM is equal to our variance divided by the sample, the size of the sample. So we have, we're going to go ahead and take our standard deviation here and square it to get the variance divided by our n of 60. And we're going to go ahead and take the square root of all of that. And so 4 divided by 60, and you take the square root, that is going to give us an SDM of 0.2582. So that is our standard deviation of the distribution of means. So now we can go ahead and we can calculate our z. And so you want to go ahead and take a look at page 163 in the text. And here we see that our value of our z is going to be our mean of the sample minus our population mean. So this is our mean of the distribution of means divided by our population standard deviation of the distribution of means, which we just went ahead and calculated right there. So this is equal to our sample mean, which is 10, minus our population mean, which is 8, divided by our standard deviation of the distribution of means, which is 0.2582. And so when we calculate that, we see that our z-score is 7.75. So when we look here, it's always good to think here about, here's our cutoff score, and think about where would this 7.75 land? Well, 7.75 is more extreme, or it's greater than 2.58. It would be somewhere out here in the tail. So we would say that yes, we will go ahead and we will reject our null hypothesis because our value here of our z is more extreme than our cutoff value. And remember, this is a two-tailed test, so if our value were more extreme than either the positive cutoff value of 2.58, so greater than this, or more extreme than our negative cutoff score of minus 2.58, so more extreme than this, or more negative than 2.58, then we will go ahead and we would reject our null hypothesis. So our sample score here is extreme enough to reject the null hypothesis. The next thing that we want to do is we want to go ahead and calculate our confidence interval. And remember that we are calculating our confidence interval for a 99% confidence interval. And I'm going to go ahead and abbreviate confidence interval with a CI. And so let's go ahead and calculate this. And so when you are calculating the confidence interval, you will find it helpful to go ahead and take a look at pages 168 through 170 in the text, and that will be helpful for you. The information that we need for our confidence intervals, we're going to go ahead and need our standard deviation of the distribution of means, and then we need our sample mean here. And so when we're calculating our confidence interval, we're going to go ahead and let's calculate our lower confidence interval first. And so what we do here is we go ahead and we're going to go ahead and put in our cutoff value here of minus 2.58, because we're looking at 99% confidence interval, times our standard deviation of the distribution of means, that's a mouthful, plus our mean, our sample mean. So this is minus 2.58 times 2.2582 plus our sample mean of 10. And so this gives us a value of 0.933. Let's go ahead and let's calculate our upper confidence interval. And remember, this is a 99% confidence interval, so we're using 2.58. If you look at page 169 in the text, you'll see that if we were calculating a 95% confidence interval, we would not be using a positive and negative 2.58. We would be using a positive and negative 1.96. So go ahead and look at page 169 in the text for more information about using the value for the 95% confidence interval versus the 99% confidence interval. So again, we're taking our positive 2.58 times our standard deviation of the distribution of means plus our mean. So that is simply 2.58 times 0.2582 plus our sample mean, which is 10, and this gives us a value of 10.67. So our upper and lower limits for our confidence intervals are 9.33 and 10.67. So we can be 99% confident that the true population mean is between 9.33 and 10.67.